Hello everyone. In this class I am going to discuss about the transformers. The transformers, as we know, are the most important components of any power system, and this transformer actually can accept energy at one voltage level and can deliver at another voltage level. So the change in the level of voltage is possible from one side to another side of a transformer, and that's why the transformers are used extensively at different stages in the power system for transmission and distribution of power. Now, actually, in a case of a transformer, a very low voltage can be converted into a high voltage, which actually converts the current into the lower level. That means if the voltage is increased, the current can be reduced, and that reduction of current also leads to reduction in line losses and also the voltage drop. Okay, so that's the advantage of using a transformer and increasing the stepping up the voltage level. Okay, so transformer actually consists of number of coils. Okay, one set of coil is called as the primary coil, the other set of coil is the secondary coil. The primary coil is connected to the source of the power, and the secondary side is connected to what is called as the load. Now source means generator and load means the utilities, the utilization of power that happens in the lights, fans, motors, pumps, etc. So different types of energy consuming devices are actually the loads. Okay, so in case of a transformer, there is a term called as the turns ratio. Turns ratio is the ratio between the number of turns of the coil in the primary side and the number of turns of the coil in the secondary side. The ratio is exactly the secondary side number of turns divided by the primary side number of turns. Now secondary voltage is actually determined from the turns ratio by multiplying the primary voltage with the turns ratio. So that means if the primary side number of turns is, let's say, 5 and the secondary side number of turns is 10, so then the voltage in the primary side and the secondary side will be related as 2:1. That is 2 divided by 1, because the secondary side is 10 number of turns, primary side is 5 number of turns. So 10 divided by 5 is equal to 2. So the primary voltage, whatever is the primary voltage, let's say the primary voltage is 10 volt. So if the primary side voltage is 10 volt, what will be the secondary side voltage? The secondary side voltage will become 20 volt, because number of turns in the secondary side is 2 times higher than the primary side. So that's how the primary to secondary side voltage conversion can be done. If we know one of the sides of voltage, that means whether the primary side or a secondary side voltage is known and the turns ratio is known, then we can find the other side's voltage level by considering this relationship of turns ratio. Now another aspect that we have to keep in mind is that primary ampere turns is equal to secondary ampere turns. That means current multiplied by number of turns in the primary is equal to current multiplied by number of turns in the secondary. So again, coming back to that same condition where we consider the primary side number of turns is let's say 5 and the secondary side number of turns is 10. So if primary side number of turns is 5 and there is a current of, let's say, 10 amperes flowing through the primary side, if 10 amperes is flowing through the primary side, then secondary side current will be how much? That we have to find out. How much will be the secondary side current if 10 amperes is flowing through the primary side whose number of turns is equal to 5. So 5 amperes multiplied by 10 amperes is the current. 10 amperes multiplied by 5 turns of the coil is 50 ampere turns. 10 ampere multiplied by 5 number of turns. So 50 ampere turn is the value for the primary side. So as I have mentioned, the secondary side also ampere turns will be exactly equal 50. So already we know that the secondary side number of turns is 10. So secondary side current must be equal to 5 amperes, so that it becomes 50 ampere turns even for the secondary side. So secondary side number of turns is 10. So secondary side current has to be 5 amperes. Then only it will become 50 ampere turns, just like the primary side. So primary side ampere turns and the secondary side ampere turns have to be exactly same in a transformer. That's the characteristic of a transformer. All right. So another important term related to transformers is the voltage regulation. So voltage regulation of a transformer is the increase in voltage from full load to no load. So what happens is, when the transformer is fully loaded, then the voltage is slightly reduced. But when the transformer is absolutely not loaded, no load is connected to the transformer, and this transformer is on, then the voltage increases slightly. So that increase in voltage during the no load period and the decrease in voltage during the full load period, that can be found out by considering a ratio which is also converted to percentage, called as the voltage regulation. It is the percentage increase in voltage from full load to no load. So there is an increase of voltage that would take place from full load condition of the transformer. When the transformer is fully loaded, the voltage goes down, and when we remove the loads, we remove loads one by one and completely remove the loads, no load is connected to the transformer, under that condition there will be the increase in voltage. So that increase in percentage form is expressed using this term called as voltage regulation. That's another important parameter which is mentioned in case of a transformer by the manufacturer. Now, what are the different types of transformers? So transformers are classified as two categories: power transformers and distribution transformers. Now, power transformers are those larger transformers which are used at higher voltages. They are used to step up and step down the higher levels of voltages, like 400 kV, 220 kV, 132 kV, 66 kV, 33 kV, etc. However, the lower level voltage transformers, the transformers which are used for stepping up and down of voltages at lower level, they are called as the distribution transformers. So what are their voltage levels? The lower level voltages can be 11 kV, 6.6 kV, 3.3 kV, 440 volt, 230 volt, etc. Okay, now these ratings of transformers, like which voltage level and which kVA level, the apparent power level, what will be the rating of the transformer, that is calculated based on the connected load and applying the diversity factor on the connected load. Now, connected load is, let's say if you have to install a transformer in a campus, in an apartment. Okay, there is an apartment where number of houses are there, flats are there. So in that apartment you have to install a transformer. So what will be the rating of the transformer? The transformer rating will be decided by what are the loads available, what are the loads connected in that particular apartment. Now, another aspect that we have to consider here is that all the loads which are connected in the transformer, all the loads which are present in the premise, in the building, will not be switched on at the same time, but they will be switched on at different times as per their requirement. But according to the connected load, we will have to make some calculations of what is called as a diversity factor. Now, diversity factor is the ratio of overall maximum demand of the plant or a particular building to the sum of individual maximum demand of the various equipment or appliances. Now, coming back to our example of a transformer that is to be installed in a residential campus, in a building, for a building. Now, the total demand of that particular building, maximum demand of that building, will be during the evening time, peak time, when everybody is at home and street lights are switched on. evening time all are awake, till the night time when people are to go to sleep. During that the period from right from the beginning of the evening time, that is around 6 p.m., 7 p.m., etc., till late at night around 11 p.m., there will be peak time of load, because all the lights and fans and appliances will be on, and during that time we will have the maximum requirement of power, that is called as the maximum demand. However, if you add up all the ratings of different components or different equipments which are installed in different appliances which are installed in the buildings of in different parts of the building, then that adds up into another number. Now the maximum demand during the peak time will not be exactly the same as all the appliances being on, because we will not be switching on all the appliances all the time. Only some appliances are switched on during the evening time also, and therefore the maximum demand to the total amount of power that will be consumed by all the installed equipments will be considered as the diversity factor. Now diversity factor varies from one industry to another industry, one building to another building, one plant to another load, and another plant. So that is actually something which we need to see, and accordingly we have to install a transformer of a certain rating according to the maximum demand. So it is not exactly related to the connected load in total, but maximum demand is determined from the connected load by considering the diversity factor. Okay, so rating of the transformer is decided by looking at the maximum demand by the consumer, those who have installed the transformer in their location. Okay, so what is the location of a transformer? What is the ideal location? The ideal location of the transformer is near the load center. Wherever the load is, near that, if the transformer is installed, then there is less losses that would occur in the current that would flow from one point to another. That means from transformer, if the current has to flow to the load for a long distance, there will be losses in the line. So in order to avoid the losses, we will try to locate the transformer as near to the load as possible. Okay, so that is how the location of the transformer is determined. Okay, so next is the transformer losses and efficiency. These are very, very important aspects actually. The transformer losses and efficiency calculations are very, very important. The efficiency of a transformer varies anywhere between 96 to 99%. So that's a very high efficiency as compared to other types of machines like the motors and the moving part machines. The transformers have a higher efficiency of 96 to 99%, and it depends on the design also. However, the losses that occur in a transformer can be considered in two different parts. That means two different types. One part is called as a no load loss, the other one is the load loss. The no load loss is also called as the core loss. It is the power consumed to sustain the magnetic field in the transformer's core. Now transformer has a core, and inside the transformer, even when you do not connect any load, there will be some circulation of current, because the magnetic field has to be continued from the primary coil to the secondary coil through the core. So that leads to losses. One such type of loss is called as the hysteresis loss, and that is the energy that is lost in reversing the magnetic field when the alternating current flows. Now transformers work only with AC, alternating current. So alternating current goes to positive side and negative side alternately. So that also leads to a kind of a loss that is called as the hysteresis loss. Some energy is lost in the process of going from positive to negative side in the wave. So that's how the AD that's how the hysteresis loss happens. There is another loss that is called as the AD current loss. That is all that happens because of the circulation of induced currents in the core. Now core is a magnetic material, so there will be some induced current in the core that will be generated due to the current that is flowing through the coils in the primary and the secondary side. Now that is called as the AD current loss. Now what is the other loss? That is load loss, which is also called as copper loss. That is the loss that happens in the windings or the coils when the current flows, and that is given by P equal to I square R. So we will discuss about the different types of losses and efficiency again in the continued in the next class. Thank you.